Through the Australian Government Reef Trust funding, Reef Catchments have undertaken streambank and gully remediation works across key sites in Murray Creek, St Helens Creek and the O'Connell River. There were 4 main remediation methods used. These include engineered works in the form of pile fields, installation of rock groynes and large woody debris structures, streambank revegetation to reinstate an effective riparian zone, weed control to remove exotic species, and riparian fencing for stock exclusion.
So the Reef Trust 4 project being rolled out across the Mackay-Whitsunday district, the work we do, we're looking to stop fine sediment entering the Great Barrier Reef Lagoon. Not every site that you see needs rock or pile fields or an engineered approach. Sometimes we can go there, we can install a riparian fence, we can just plant a whole area to trees, and that performs a function in the landscape that stops these banks eroding, etc. And then we move on to the hard-faced engineering solutions. What determines that is site-specific.
Initially identifying cost-effective sites was achieved through prioritisation studies to understand areas with high historic erosion rates. External consultants were engaged to create technical assessments and a digital elevation model, DEM, of difference for our key river systems. This DEM of difference uses high-resolution LiDAR data from 2009 and 2018 to compare changes in elevation and provides an estimate of sediment volume lost and the erosional process at each site. This provided confidence in site selection and a great foundation for site planning.
A lot of damage being done. Seen a lot of cane farms that's been cut in half due to floods, water rising, just washing everything out. So a lot of people underestimate the power of this river. At the moment we've just finished a design or engineered project here, which had taken a lot of dirt out. Water's taking it out into Repulse Bay, which means we haven't got the water quality. It was just a straight face, so what we've done, we've re-profiled it back. This design here, we've got a flat bench at the bottom, and we've put in roughly 30 cubic metres per square metre on that bench. If it saturates and wants to collapse, the rock will fall in and self-line it. We put a deflection groyne here. The speed of the water in this river is pretty high. It's around 6 to 7 metres a second it moves. So the water hits the groyne and then deflects it off the bank, takes it more out to the centre of the stream.
The rock work and the hard engineered section of what we do, it's not different to these trees. It's providing a stable mechanism so that these guys can survive and thrive, and what you see up there becomes here, and then you've got nature doing the work for us.
So how exactly do engineered designs assist in protecting a riverbank? As floodwater flows downstream, an exposed riverbank without an effective riparian zone will likely scour and form an undercut, which can then lead to slumping and mass failure. Once the bank has been regraded and wooden pile fields have been installed, flow velocity along the toe of the bank decreases, effectively reducing the erosional force of the river. This allows riparian vegetation to establish on the bank, which helps increase the bank resistance. Armouring the bank toe by placing rock also helps to prevent scour and support riparian vegetation planting on the upper bank. The revegetation needs to be tailored to riparian environments, native to the local area and diverse in terms of rooting depth and growth speed. After approximately 10 to 15 years, the wooden pile fields will disappear, and the natural vegetation takes over the primary role of providing bank stability.
I'm a fisherman. From Repulse Bay out to the reef, it's all about water quality. If we've got healthy systems, we'll save the reef. If we can get everyone to do their little bit in these rivers, I'm sure in years to come, there'll be a a good outcome.